Yo, yo, algebrainiacs! Welcome to the Johnson-Kendro Video Hour!
But it's not an hour.
Hmm, one of these days, one of these days. Okay, we're going to talk about binomial radical expressions. We have something called like radicals. They are alike. The radicals with the same index, which is the little square root or cube root number, and the same number under the radical. So these, it's like a square root of 3 and a square root of 3. We have two of them, we have one of them. We should be able to call them like. They can be combined just like if they were x's, like 2x plus x is the same thing. So it's 3x, so on the top it'd be 3 root 3's. All right, now you can add or subtract. Let's try a few of these. How about 2 root 7 plus 3 root 7? How many root 7's do we have?
5.
Woohoo! So my answer is 5 root 7.
So we're just basically seeing if they're like and then adding the numbers in front.
Absolutely. All right, let's try another. Okay, 7, the fourth root of 5 and the cube root of 5. Those have different index numbers, so we cannot do anything here. So it's not possible.
Simplify.
Already as simple as it gets. All right, last one here. Look at the index number, the little 3, and then what's under the radical. They're the same, so we should be able to do this. 5 minus 4, that just leaves one of them. You don't have to write the 1, so it's just cube root of x, y.
1 is optional.
The 1 is optional, yes, but we are mathematicians, and mathematicians are lazy.
Okay, sometimes when you first look at the radicals, they don't look like they're like radicals. Like. But they really might be. But we don't know unless we check. So what we're going to do here is simplify all of the radicals first, and then we're going to see if they're like radicals, and we'll add them together. So we're going to split this up. This is, just leave that coefficient out in front. I'm going to split 18. We're talking about square roots here, so biggest perfect square would be 9. 9 times 2. So now I have a 6. The square root of 9 is going to change to a 3. And then you can multiply those together, so that's going to give us 18 root 2. I'm going to do the same sort of thing with these other ones. So leave the 4 alone out in front. Split this into root 4 and root 2. The 4 and then square root of 4 is 2 root 2. That is 8 root 2. And then last one, I've got the minus 3 out in front. I'm going to split 72 into root 36 and root 2. So that becomes minus 3 times 6 times root 2. So that'll be a negative 18 root 2. And now, are they like radicals?
They all have root 2's.
That's right, square root of 2. So then we would put them all together. Well, I see right away, these are going to cancel. So 8 root 2.
All that for that little amount.
That's right, but we wouldn't know. At first glance, if you just looked at your problem, I'd say, ooh, not like radicals, and wouldn't be able to do it. So, all right, let's do another one. Same sort of thing. So let's split 50 into...
I want to split it into 25 and 2. So that's really 5 root 2. Now I'm going to split the 32. I have this plus 3 here. The 32 becomes, we'll say, square root of 16 and square root of 2. So that's 3 times 4 times the square root of 2. And let me rewrite one more time. 3 times 4 gives me the 12. Over here I have minus 5, and then I have root 9 times root 2 would be the root 18. So that's 5 times 3 times root 2. That makes 15 root 2.
Ooh, they all have root 2.
All right, so that means we can put them together. These two make 17, and this one minus 15. That would give me 2 root 2's.
2 root 2. All right, let's move on to the next topic. So now we're going to multiply.
Multiplying. Okay, just think of this as a FOIL problem, just like we've done for many months. So you're just going to take the first, let me get that, first times the first. That would be 6. Then I have first times the last out there. That would be plus 12 root 5.
You don't multiply the 3 to the root 5.
Oh no, the outsides go with outsides, the inside, the root goes with the inside.
Okay.
Okay, so there's no other root here. So I don't have anything to multiply there. So now I have 2 times 2 and then the root 5. So that's 4 root 5. Now I have an outside and an outside. That's 8. And then the two roots I can multiply together to get root 25.
Ooh, we know that.
Root 25 is?
5.
Just plain old 5. So this is really 8 times 5 or 40. So let's rewrite everything we have. 6 plus. Now I can put those two together because they both have root 5s.
They're like radicals.
They're like radicals. So 16 root 5. And then I just have the 6 and the 40 to go together. And we say the rest is history.
Okay. Let's do it again. So there's this exponent on the outside. Can I just like distribute that and that's going to undo the radicals or something?
No, ma'am.
How come?
The 2 means whatever's in that parentheses has to be written down twice.
Yeah. Whenever there's addition in there or subtraction, can't distribute. Can't really distribute exponents anyway, but that's what kids like to say. Okay. We've got nothing on the outsides except for ones. So we're going to FOIL first times first. So 1 times 1 is still just going to be 1. So I'm going to have root 4. I'm going to change that a little bit later. Outer times outer. I've got positive 1 root 2, and then that's really a negative. So it's going to be a negative root 6. Then inner times inner is also a negative root 6. And then last times last, negative times negative is a positive. Root 3 times root 3 is root 9. And then we can do some simplifying. Square root of 4, we know that, that's 2. I can put these two like terms together. This is a negative 1 and a negative 1, so negative 2 root 6. I can also put, simplify this, that's a 3, and then now we have like terms here and here. So final answer will be 5 minus 2 root 6. All right. Something special can happen, and we've actually used conjugates already in some different things with our imaginary numbers, but now we're going to do conjugates here with radicals. So I had a simple example here that doesn't have radicals of conjugates. Those are things that it's exactly the same in the parentheses except for the middle sign. And if you remember doing these, when we FOIL, we get x squared. This is minus 5x and plus 5x in the middle, and then minus 25. And this is special because those middle things cancel. And that will be helpful when we multiply conjugates of radicals because I'll do root 2 times root 2 and get root 4. Root 2 times minus root 3 is going to be minus root 6. Then inner times inner is plus root 6. And last times last is minus root 9. When I go to do like terms, those middle things cancel. Also, you'll notice I know the square root of 4. I also know the square root of 9. So I'm left with just a normal old number with no radicals at all.
All right, so here's a problem where we need to rationalize the denominator. You guys have done that before. That means you got to get the radical out of there. And the only way to do that is to multiply it by itself, but with...
Wait, I can't just do that?
Oh my goodness. Back it up, John. There we go. No, you can't cancel when there's plus or minuses. It has to be multiplication to cancel. So the only way to do this is with the conjugate. And you always look at the denominator and you take the opposite sign. The numbers stay the same, but the sign is opposite. And we would do it to both because that's really the form of 1. This whole thing here reduces down to a 1, so we're not changing the integrity of this fraction. Fancy word, integrity. It's good to have in real life too. All right, so now it's just a matter of foiling top and bottom. So I'm going to take the first two, 6 times 4, the outers, 6 times root 15, the inners, 4 times root 15, and the last root 15 times root 15, we're just going to call that 15. Now we take the outers here, we got 16, or the outers here, those were the first, and then 4 root 15. The inner would be negative 4 root 15, and then the last negative times a positive is negative 15. Root 15 root 15 would be just 15.
Cool.
Now we can just put stuff together. We have 24 and 15, that's 39. Then we have 10 root 15 for the other two. Then we have 16 minus 15 is 1. These two cancel out. That's what's supposed to happen when you rationalize. All the radicals are supposed to go away from the denominator.
Will it always be a 1 down there?
No, just kind of coincidence.
Okay.
So there's the final answer.
Should we do another one? Maybe. There we go.
There we go. All right, let's try this one. So we need to rationalize here. So I'm going to do the denominator again. It's going to be 4 minus root 3 on both. And now we just start foiling. So 2 times 4 is 8. 2 times negative root 3 is negative 2 root 3. Inner is negative 4 root 3. And last is positive
3.
root 9, which is 3. Yes. So 4 times 4 is 16. 4 times negative is negative 4 root 3. 4 times positive is positive 4 root 3. And root 3 times negative root 3 is
Negative 3.
Woohoo! So I can put things together.
The top.
The
Got
tops.
like term.
8 and 3 is 11. Negative 2, negative 4 is negative 6 of those pesky little root 3's. 16 minus 3 is 13, and then these two go away like they're supposed to, and we're done. You could try to do heart surgery here, but in this case, nothing is going to simplify.
All right.
All right, I think that's it.
Okay.
Have a good one.
Ta-ta.